Welcome to the future.
Okay, so we're going to be taking a look at the original barbecue controller that came in my Traeger BBQ. As you can see, there's not a lot to it. You just kind of dial in the temperature you want. It's just like an oven. You just, away it goes. Yeah, and then you can see 375. This might be 400. And then high is just anything above 400. And yeah, my barbecue won't get too much higher than 400 degrees. It might get to 425 or maybe 450 on a really hot day. But anyway, we're not concerned with that. Yeah, it just has a regular digital readout, and that's about it. The smoke mode right here is actually settable through a little button or a little hole right here. Let's see if we can see it. You stick a paper clip through that hole. I forget the exact procedure. I'd have to look in the manual. But anyway, it pushes that button right there, and you can change the temperature of the smoke mode. And I forget what it is. I'm not going to look it up, but I think it defaults to 180 or something like that. Or actually, it changes the duty cycle on the auger running, you know, how many seconds on versus how many seconds off the auger dumps pellets into the barbecue, right? Yeah, let's take a look at this thing. You can see we're on Grill Digital version 1.2.080528. That looks like a date code to me. Let's see, was that May 28th, 2008 maybe? Yeah, and that sounds about right. My barbecue's about 10, 11 years old, and actually this is the second controller I put in it. The first one actually died. Anyway, let's take a look at it real quick. We've got a in-system programmer right here. That's for programming it after it's been assembled. Looks like we've got serial inline resistors. I think it's called a serial inline pack or something like that. But yeah, it looks like it's just about 3 resistors, or 4 resistors, sorry, all tied together. And we've got a couple transistors here and some SOT23 packages. Here's more of those packages, resistors, and this guy right here, I can't hardly read it. It looks like a UTC something. Anyway, let me Google that and see what it is. That's a dual op amp. Okay. And let's see, we got a little micro right here. Oop, I think I got them upside down. I think I read Atmel on there. Yeah, I got us a little Atmel microcontroller. You guys can probably read it better than me. I think it's an AT Mega. Okay. What do we got here? We've got a it's like a 8 megahertz crystal oscillator. And some more of those SIP resistors. Got a diode there. Yeah, right down here is a diode. More of these SIP resistors. Here's a test button. Or I guess, well, I don't know what the button's for. Maybe it's a reset button, and the jumper's for test or normal mode. Oh, sorry, I have it upside down, don't I? Let's see here. What do we got right here? It looks like they're light on opto-couplers. Okay, and that's how they're controlling the relays, going from the high voltage side to the low voltage side. And okay, we've got here's where you connect the RTD temperature chamber probe, temperature chamber probe. It's a PT-1000, and I wanted to show you, see how it's bent. See how it's bent on the board? That's because when you tighten these screws up right here, you tend to tweak that. So, and it turns this this 2-post terminal block, it's going to twist it off eventually. So yeah, that needs some better binding posts on there. Probably something that, you know, mounting holes on the bottom, you know, to keep it from twisting like that. Okay, so we looked at our opto-couplers. Let's see, what do we got up here? I can almost guess what that is. There we go. It's a 7805 voltage regulator. Yep, that's kind of hanging there, flapping in the breeze. Got us an electrolytic cap there. And, man, I tell you, this this humongous transformer right there is causing big time focusing problems for my camera. Sorry about that. Let's see, can we get this to focus? Okay. Yeah, this looks like a full wave bridge rectifier. Yeah, and then we've got some caps, and I've actually looked at these already because the writing on them is so bad. They're kind of all stained and hard to read. But they're 1 kilovolt, 0.01 microfarad power caps for mains power, and that is, I believe they're tied to these triacs right here. Yeah, so I can see the ST micro. I can't really read the model number on that. Okay, I went and looked those up real quick. They're ST micro BTA-12 triacs, and we've got. Looks like I'm gonna turn it upside down. Maybe be easier to see them. We've got 3 of them. This one says fan. It says danger. And oh, I can see auger right there. We can't really see this other one. But yeah, we've got all these 1 kilovolt, 0.01 microfarad caps right here. Looks like we've got 1, 2, 3, 4, 5, 6 of them. So I don't know, maybe 2 per triac. I don't know. Alright, so we've got a fuse, and I believe that's a 3 amp fuse. It says hot and neutral, so this is mains power coming into the board. You can see the outline right here where it outlines where the main side versus the the digital side, or the low voltage side, I guess. So yeah, so all this right here. So let's look at this transformer. It's looks like 110 volt, 2.5 volt amps, and it steps it down to 8.5 volts. Oh yeah, there's another date code. So it's a 12/23/2008, and I think that's it. I'll have to let me take it apart, and we'll look at the other side. You can see the how the knob is just bolted right on this faceplate here. And then they've got, looks like they've got a couple trimmer pots in here or something. Looks like it's going for the RTD. I guess you can adjust the RTD temperature. That's kind of interesting. And they just have this header right here that's driving that's connected to the LED. So I looked up the name of this LED down there. I don't know if you can see it. It's Lucky Light KW3-392C something. Anyway, it says it was surface mount. I don't understand. That doesn't look surface mount to me, but maybe they've welded these. Maybe they've welded these header pins onto this board right here, and then just welded it. Looks like it's welded straight to the PCB. Well, yeah, that's kind of interesting. So okay, anyway, that's I just wanted to show you what it looked like assembled before I take it apart. Oh, here's got another opto-coupler hiding down here. So, all right. And I just pulled that nut off there, and I was looking at the stem on this thing, and look at this thing. It is just a cheap piece of plastic. It even felt like it was like cross-threaded on there. Go figure. Well, there's not a whole lot holding that PCB on there. Basically one screw and the selector switch nut. The plastic one. So, it didn't take long to take it apart. It looks like we've got a couple trim pots up here. Don't really know what they do. Oh, here we go. Here's our lucky light. Now we can really see it. It's KW3-3392 CUAA. Alright. This is that button that was changed the duty cycle for the smoke mode. And it looks like we've got a diode down here and some caps. I'm guessing probably for this display. We got another resistor pack here, it looks like. Here's that other photodiode. And yeah, I didn't know this board was going to be double loaded like this. A resistor pack. Oh yeah, so you can see the outline of this much better. It's kind of nice. They've got the outlines for the resistors right here on the back side, so because you can't really see them on the front side. That's kind of nice. So this is the high voltage side. It's all outlined. That's nice. 110 to 220 volt. Okay, so this will do 220 as well. I was kind of wondering about that, but you know, I don't know how it could do 220. The transformer is only 110, only rated for 110. So yeah, I don't think that's labeled correctly. I don't know, maybe they can just change the transformer out for different areas. Well, that's it. Yeah, not a lot to that guy. Yeah, I had no idea there were going to be more passives on the bottom here. Okay, so I went ahead and put together a little schematic that I drew of the Traeger controller, right? Originally I had guessed at what I thought it looked like, but I was wondering what the second cap was for. And so I started digging in a little bit to see if I could uncover what it looked like, and and ended up redrawing pretty much everything. So I went ahead and traced everything out, and that's why all these caps and resistors have designators by them that match the PCB that's actually on the PCB. Okay, I only did the section that had the triacs and the opto-couplers because that to me is the most interesting. The micro and crystal oscillator and that sort of, debug port, in our system programmer, that there's videos out there about that. I was mainly concerned on how they are implementing these triacs and opto-couplers, right? And I went ahead and drew out the power section because it was pretty simple. I didn't really trace this out either. I just took a best guess at it. And also another thing I was interested in was this section over here, which is the where the RTD plugs in. Okay, and I was interested with this because of the two trim pots in there, and I didn't actually trace it out. This is kind of my guess as well, but I did take a close look at this LM358 dual op amp, and my drawing is pretty close, except for where these 10Ks are. They have other values in, and they also added the trim pots. And I didn't really trace that out. I'm guessing they're trimming these resistors right here going to the RTD, and we'll look at that here in a minute. But let's start from the top, okay? Okay, so I'm gonna just zoom in here, and okay, so the barbecue is powered by mains. This is a socket for a plug. And I went ahead and labeled them L1 and neutral and ground. And this ground is an earth ground. It's actually tied right to the barbecue. It's a safety equipment ground. Okay, and also on the neutral right here, I show it going to a COM, which is common, And this common ties to all the other commons for the igniter, the auger, and the fan motor, okay? All right, so we go through, so from the line side, we go through a fuse, then we go into our transformer, that big-ass transformer. That's okay, and so, yeah, from the transformer, just in the secondary winding here, just goes through this full-wave bridge rectifier, then through C4. It's just a jelly bean configuration. These 7805s have been used for forever. And then it goes, so we got the unregulated input, and then this is just ground and the output. And one of the things I thought was kind of interesting is I drew this cap right here because usually on the output of a regulator, you put an output cap, and they didn't. So if you look at the 7805, you can see it has an input cap, 0.33 microfarad, and an output cap, 0.1 microfarad. I forget what size this cap is. Maybe when I'm editing it, I'll put a note up top here. But yeah, they just omitted this output cap altogether. So anyway, seems to work okay. And by the way, I just want to mention that I think the layout and design of this board was done very nicely. It seems to follow all the recommended layouts for all the chips, and you'll see some of that as we go along. But I just wanted to make that comment that I thought they did a pretty good job. It looks good to me. So okay, so we've done the AC power. So after the fuse, they come off with a 120 volt line to come down here and feed A2 of the triac right here on all the three different circuits for the auger, the igniter, and the fan. And they're all pretty much identical, so we'll just look at one. And in fact, all the resistor values are the same. I wrote 270 on this one. It's a 270 ohm resistor. Okay, yeah, so this cap is a 10 nanofarad polypropylene 1 kilovolt AC mains rated capacitor. This is our triac right here. This is mains feed right here. This line right here comes in. It also splits out through this little network right here. This is what feeds the opto-coupler, and this is a triac, or opto-triac is what it's called, I think. And so it's got another little triac inside this guy. Yeah, so when it gets enough gate current going into this ST triac, the main triac, if you will, then it turns on and it starts allowing current to flow into the motor, all right? And this right here is a snubber network, and this was that second cap. Oh, so here is the original cap. And by the way, all these caps are the same. I don't know if I said that already. They're 1 kilovolt, 10 nanofarad caps. Yeah, this is a snubber network right here. And so yeah, so they added this the snubber network on here, which is good. Although I believe I was looking at the ST Micro data sheet, and these things have a 600 volt rating. I think can be used without a snubber network, but these guys went ahead and added it anyway, which is good. It's a good attention to detail. And by the way, so this is a BTA-12 triac. It says the snubberless version. I guess if it has a W suffix, it's a snubberless. So I guess the snubber circuit is needed on this track. Yeah, so this BTA-12 is a 12 amp current handling capacity with 600 volt VDRM VR. Basically, that's how much voltage it can handle when it turns off. It's kind of a blocking voltage, I guess. And we're going to be we're not using the snubberless. We have the standard, and this is the gate current to turn it on. 50/25. So we'll take a look at this opto-coupler here real quick. And it is a light-on photocoupler, MOC 3063 is the model number of it. That's that's on this board, and here's the pinout for it. And this is an interesting little device. So it has an isolation voltage between input and output of 5,000 volts. That's between the opto side and the triac side, or the LED side and the triac side. It's a 6-pin dip, high repetitive peak off-state voltage, 600 volts. Here's the high critical rate of rise of off-state voltage, DVDT, 1,000 volts per microsecond. It's a dual inline package. See, we're using the 3063. Wide lead spacing, surface mount, tape and reel. Its applications are AC motor drives, starters, contactors, lights controls, temperature controls, solid state relays, and static power switches and temperature controls. Okay, so moving on, that's pretty much it. The auger motor is just a regular motor. The igniter is a resistive load and really doesn't even need the snubber network. And the fan motor is just another inductive load. So, and all these circuits are identical. Like I said, I traced them out, so this is exactly how it is laid out on in the Traeger controller, right? And I drew these out originally, kind of show what I thought was a control circuit for it. There's 3 transistors. Yeah, so you see these 3 transistors right here. Okay, well, we've got 3 outputs, auger motor, igniter, and fan motor. I assume those 3 transistors were used to drive the LED inside the opto-coupler. But I am incorrect. I actually traced one of these guys out. You can see right here, it goes up and it goes into this resistor pack, which goes straight into this in-system programmer header. So I don't know what they do, and I didn't bother to trace them out. This layout here is not correct. I did actually trace out one of the opto-coupler lines. So the pin 1 right here is the anode side, and this is the cathode side of the LED inside here, right? And if you follow this, let's see if we can see it. You can see it comes out pin 1 and goes into this 10K resistor, and then goes up underneath, little jumper right there, underneath this button. It kind of comes down right down through here, and then goes straight into the micro. So they're basically driving this opto-coupler straight from the micro. All right. So, yeah, and I didn't bother putting it on the drawing right here. It wasn't very interesting. Okay, so the last thing I wanted to look at was this dual op amp right here, this LM 358 op amp, and how it had a couple trimmer pots. I pulled up some pictures. Here's the 2 trimmer pots. This is the bottom of the terminal, 2-post terminal block. Let's see, here we go. Here's a picture of it. Yeah, so this right here is the bottom of this. You can see the 2 trimmer pots right here. And if you look right here, this is one trimmer pot, and the other trimmer pot is, you can't really see it, but it's mounted right there. I see 2 traces coming out. One's going into this terminal block right here. And then it's also looks like it's being trimmed by one of the pots. And then we've got another one line coming out. This is probably some kind of voltage divider that's also being trimmed by the other pot. And so if you look right here, so pin 6 right here is the inverting input, and pin 7 is the output, and pin 5 is the... Well, after taking a closer look at this thing, I'm not exactly sure what they're doing here. Yeah, I double-checked. They actually have pins 5 and 6 right here tied together. That's a trace. And I actually put it on the microscope and verified that. And I don't really see any other traces coming out here, but that doesn't mean anything. They might have a via. I see a via right here. So yeah, I don't know. Yeah, so this is definitely pin 1. And this should be going to the power in. And 4 should be the ground. And maybe they are using this second op amp, and I just can't see the traces, like I was saying. But it just dawned on me. I know what they're doing. I bet you $1 to a donut hole. These 2, this trace right here is going to ground, and so what they're doing is they're just grounding the unused inputs of the op amp. right? And I could go test it, but it's not that important. All right, so it looks like they're probably just using the A side, which is, so here's the output. And this via right here looks like it's tied to pin 1, and these other 2 are probably going into the pins 2 and 3 of this op amp right here. Before I finish right here, this micro right here is a Atmel. I pulled up the spec sheet on it somewhere. I was looking at this thing, and it's pretty nice. One of the things I noticed about it right here is that, okay, so in the dip package right here, it's got a 6-channel ADC, but it's got 10-bit accuracy. That's pretty good. I don't think the Arduino Mega had 10-bit accuracy. I'll have to go back and check that. But that should be more than enough for a PT-1000 RTD. We're going to revisit this probe section in a future video. That's it. Yeah, it's a pretty nice board. It's all laid out nice, and I don't know if you noticed, I removed the humongous transformer and the wires on here so I could trace it out a little better. You see I made some notes. So yeah, thumbs up. It's a nice little controller. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button. That really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.